PWM is another interesting topic for AVR. You can use PWM to generate various frequencies. These frequencies can be used to control intensity of a LED, control speed of DC motor, generate interesting sounds, etc. Let's understand how to generate a PWM. Pulse width modulation uses a square wave whose duty cycle is modulated, resulting in the variation of the average value of the waveform. Look at the graphics on your screen. For a given time t, first figure indicates that the pulse is at its peak for 75% of the time. Whereas in the second figure the pulse is at peak for 25% of time. Let's make a LED dimmer application using PWM and timer. Pin PB3 of Omega32 has to be used as PWM output pin while using timer 0 to generate PWM output. You can use PD4 or PD5 pins if you decide to use timer 1 to generate PWM. In our example we will use PB3 to generate PWM. To achieve a dimming effect of LED, we need to change the duty cycle of PWM. In simple word, the PWM pulse should be at its peak for variable time to see the LED dimming effect. A fast PWM mode is used in this example. PB3 pin is set to high as timer starts. PB3 pin goes down to 0 as TCNT0 crosses OCR0 value. PB3 pin remains low till TCNT0 reaches its highest value. We will use 1 MHz internal clock for this applications. The steps to implement PWM are really simple. A simple logic of incrementing OCR0 is used to achieve variable duty cycle. OCR0 is initialized to 10 and is incremented by 1 every time a compare match occurs. This increment is done by the interrupt handler. We have used 1 MHz internal clock with prescaler of 64. A fast PWM mode is used indicated by bit 6 and bit 3 of TIMSK. The bit 5 of TIMSK indicates that pin PB3 should be clear to low as compare match occurs. I am sure if you read this in the previous screen for 2 or 3 times, you should be able to write your own source code using timer 1 for Omega32. You can replace LED with a piezo buzzer to get sound effects. You may experiment with different